Understanding core OSPF design. OSPF is the most popular interior gateway routing protocol in the world. So it would definitely behoove us to take some time to understand the design behind OSPF and why things are the way they are. When you start setting up OSPF, the first area you must create is area 0, the backbone of your system. And all routers go into that. Essentially, as you configure them, you put them in area 0. And that simply means that all those routers will have the same topology table. You might remember in OSPF world, there's 3 tables. There's the neighbor table, which lists the routers that they form relationships with. There's the topology table, which is the roadmap of the network. So if there's, let's say, just 20, 30, 50 routers inside of this area, the topology table has every single route that exists in that area. The best routes, the second best routes, all of the different routes. And then it chooses the best of those routes and puts them into the routing table, which simply is the best of the best. So here's a fact. You might want to commit this one to memory. All routers in an area will always have identical topology tables. They all have the same roadmap, right? Just like you and I sitting in, we'll say the United States of America, we would all have the same roadmap of the roads that exist here. But based on where they are, they will have different routing tables. My starting point is Phoenix, Arizona. Maybe someone else's is Seattle, Washington, right? We're going to have very different best routes of how we get around this location, right? So that's the same idea with the OSPF areas. So the next logical question would be, why do we do this? Why do we start breaking into multiple areas? Well, the larger your area becomes, the less efficient it is. Again, going back to us as human beings, if we have a roadmap that's focused in on Phoenix, Arizona, you can really see and quickly dissect the information that you need versus trying to find those same roads in a world map, right? It'd just be too much information, too overwhelming. Same thing with the routed world. Also, any single time a route fails in the area, all the routers have to know about it because they all have exactly the same topology table. They have to have that same roadmap. So you might end up, as your network grows larger and larger and larger, with big inefficiencies. So we break into multiple areas so that we can divide those topology tables. The routers in area 2 will have a different topology table than the routers in area 0. Why? Because the area boundaries introduce an opportunity for summarization. That's really the big feature that you gain. The ability to enter a summary route. See, these area border routers, which is what we call these routers with interfaces in multiple areas, are one of 2 router types that have the ability to sum up the network. So in area 0, we might say, I'm going to use all 10.1 networks, right? So maybe I've got a LAN interface here that's 10.1.1.0/24, and a WAN interface here that's 10.1.5.0/24. Again, all these different little networks inside of here. Well, again, a nice lazy summary route might say, I'm going to sum all those up to be 10.1.0.0/16 when I inject that route into area 2. And now I represent maybe hundreds of routes in area 0 with a single route. Makes it very efficient. And also, if one of those routes go down, let's just say this network goes up in flames, it's down. All the notifications are constrained to area 0. Wherever that summary route prohibits the detailed information, it says, okay, everybody, hey, the network down, network down, network down, and spaz, spaz, spaz. It hits this router wall right here, goes, okay, well, you know what? You don't need to know because you don't even know about that specific network anyway. I've summed it all up. That's why I'm saying our goal is to localize those updates within an area so we don't send all those updates all around. However, to make this all happen, you have to have a hierarchical design. And that goes back to the example I was giving. I said, let's pretend that we have all the 10.1 networks over here, right? I did that for a reason. If we're going to summarize, we have to have contiguous, meaning all the same kind of networks within an area. I can't start throwing in 172.16 networks because I can't summarize those, at least not as easy as I can if I keep them all in one. So you've got to be very methodical. You have to have good planning in place in order to use areas effectively. Last couple things. First off, I want to make sure I mention the other routers. I said, okay, this is one of 2 routers. This is the other router type that can summarize, but it's a different kind of summarization. An autonomous system boundary router in the OSPF world bridges outside worlds into OSPF. Now, looking at the cloud, you might be like, okay, that must be the internet, right? It could be. It could be, but it could also be maybe another kind of network. Maybe you've got somebody over here running EIGRP, right? Maybe you've got two different company divisions that have chosen to use two different routing protocols. And that, I know it sounds weird because at least for myself, I deal with a lot of small, mid-sized business. I'm like, what kind of maniac would do that? Well, big companies, they're all maniacs out there. Essentially, as companies grow larger and larger, they start developing factions and they have their own IT departments and they run their own thing. They don't have central control and all that kind of stuff. So they, one division might choose EIGRP and the other OSPF, and that's cool, right? Because then we can redistribute between these two protocols. It's a little more ideal if we keep it all the same, but at the same time, people are people. They choose their own protocols. Those guys, so ASBRs, can summarize between those two different routing protocol types. Last topic for discussion, virtual links. OSPF has rules of engagement, and one of those rules is that all areas must connect to area 0. It's like the human body, the backbone. It's the first area that you create, and from there on out, all the areas have to attach. Now, one thing that I didn't mention is you might go, well, how big does an area have to get before you decide to split? Well, honestly, it's up to you, which is why you never see a best practice guide. But I would estimate about 50 routers. Again, Jeremy-ism, don't take that as Cisco best practice. It's just usually by the time you get to 50 routers, you're like, it's getting a little woolly. I want to make it clean and make it efficient, so you start dividing into multiple areas. And usually, now I'm not giving, these are all just kind of general feel. Usually, these areas represent major geographical areas, right? So this might be the United States of America. Maybe you branched out into China and you started creating an area over here. You got your 50 routers in China. You've branched out to Africa and you've got your 50 routers over here in Africa, et cetera, et cetera, et cetera, right? Well, that rule that everything has to connect to area 0 may end up getting stretched a little bit when, let's say, Africa acquires another company. There's another organization out there. You do a hostile takeover and now want to assimilate their network into yours. Well, their network, it may be very cost prohibitive to get a direct connection from their network back to the United States, wherever they're located. Maybe the cost of connecting to a router in area 2 would be, we'll just say $500 a month. Whereas if you get a direct connection from this to USA, maybe either they just don't even have it in that location, or maybe it's it's $50,000 a month, for a connection like that. So what you might have is a requirement to connect another area over here in. It could be another area 0. It could be an area 3. I mean, however you design that is up to you. Either way, this is where a virtual link comes in. All a virtual link does is essentially trick that area into thinking that it's connected directly to area 0. If this is another area 0, essentially this area believes it's like one big ol' area 0 and area 2 is over here. Right? It kind of tricks it. Think of this like an OSPF VPN connection, and there's actually more truth to that than you would believe. It's like a tunnel that tunnels this area in to, again, trick it. So whenever you hear me say words like trick, do you think that would be a good design? Like you're like, oh man, I totally plan to put virtual links in this. No, you're bending the rules. You don't want to do this. It's just you may end up in a point where you have to, and that's where virtual links come in. Virtual links trick the outside areas to believe they are directly connected to area 0. That is it. You now understand why we have OSPF areas. You understand the two major OSPF router types, that's the ABR and the ASBR, and you understand why we might do something like OSPF virtual links and what they provide for us. I hope this has been informative for you, and I'd like to thank you for viewing.